Terahertz spectrometers use invisible light to see through objects, including living tissue. These T-rays are an emerging technology that allows objects to be imaged and analyzed. It's a form of radiation that is non-ionizing and believed to be non-destructive. An alternative to X-rays and ultrasound, Terahertz technology generates a light that can't be seen by the naked eye, but it can see what lies beneath the surface. The technology has potential applications in the medical, security, and manufacturing fields. Production starts with the circuit board holder for the transmitter sensor head. Computerized tools drill a hole into a cylindrical piece of brass and carve ridge slots to hold the circuit board. Another tool transforms a second brass cylinder into the main body for the sensor head. This is the completed sensor head body. A technician screws an optical collimator into the housing. This device separates the laser light into parallel beams. He inserts a lens in the housing. The next piece he installs adjusts the position of the circuit board holder in the spectrometer. He selects a circuit board. It has a sensor chip in the center that emits terahertz light. He places it into the holder and slides the holder on the sensor body. He uses steel pins to lock it in place. The worker fastens a larger lens on the end. A device holds the sensor head in place as he tweaks the position of the circuit board. It must be perfectly aligned in order to receive the laser beam. He attaches a round circuit board to the sensor head. This board will allow the sensor head to establish electrical connections. Next, he installs the collimating module. This device has a larger lens than the sensor head, so it can send parallel terahertz beams further. He attaches a retainer ring to the module. The technician screws the collimating module to the sensor head. Now the spectrometer transmitter is complete. He slides the base of the stand into a rail system. He installs a receiver at the other end of the rail and connects fiber optic cables to both the transmitter and the receiver. The next technician assembles the optical chassis that scans objects for imaging. He installs lenses in specific locations within the aluminum chassis. He attaches a mirror to a rail in front of the lenses. The moving mirror will bounce laser light to scan images. He tests the rail system to make sure it shuttles the mirror across the spectrometer chassis. The technician places the chassis on a steel panel and wires the fiber optics throughout. He connects the fiber optic cable to the laser generating unit. He screws an acrylic glass cover to the chassis. Then he secures the chassis and laser unit to the cabinet panel. Technicians mount the panel to the back of the spectrometer cabinet using brackets and screws. Once it's solidly in place, they install the cabinet door. The door allows for easy access during servicing. They lock the door, then screw on the top lid. The spectrometer is ready for the transmitter and receiver assembly. The technician pushes the fiber optic cable through a hole in the lid and makes all the connections. He tests the device using a plastic bottle. The transmitter sends terahertz light through the bottle to measure its thickness and analyze its chemical composition. The receiver collects the data for computer analysis. This terahertz spectrometer is now ready to scan objects and show them in a new light.